Physics causes a lot of interesting things to happen, including this. This is called a Newton's cradle, and it's a great demonstration of how collisions work in physics. Why does it look like some balls move and some stand still? Let's start with a single collision between two balls. Notice how the first one hits the second, and then the second shoots out while the first one stops completely? This is called an elastic collision. In an elastic collision such as this, the objects bounce off of each other and both momentum and kinetic energy are conserved or remain constant. Let's take a look at the math. We start with momentum, p, which equals mass times velocity. Since momentum is conserved, that means the total starting momentum of the system, which includes ball 1 and ball 2, is the same as the total final momentum of the system. Kinetic energy, k, is also conserved, and kinetic energy is equal to half of mass times the velocity squared. Now we can substitute. Since the masses are the same for each ball, we can use a single mass, m. The initial velocity of the second ball is 0, which cancels some terms. We can simplify this algebraically, then set them equal to each other. Finally, we simplify this to find that v01 equals vf2. So the initial velocity of the first ball is equal to the final velocity of the second ball. This is also why the first ball stops completely, because it moves at the initial velocity of the second ball, which was 0. Since each ball is a pendulum, gravity causes the second to go back down, hitting the first and exchanging velocities again. Now let's see what happens with three balls. If the second ball is supposed to move at the velocity of the first, pre-collision, why does it stay still instead? It doesn't, it just looks like it does. What if we give it a little more space? Wow! See how the second ball moved quickly before hitting the third? The first two collide and exchange their velocities. So the second one moves towards the third at the initial velocity of the first ball. It then hits the third, resulting in another elastic collision. This time, the second and third balls exchange velocities, and the third ball, with nothing in its way, flies out. This is true no matter how many balls you add, because the same velocity exchange occurs. And the middle balls only look like they're not moving because the collisions happen so close together. The end ball has nothing to collide with, so it moves until gravity takes over, pushing it back in the other direction. Here's what you need to remember. In an elastic collision, the objects exchange velocities. So why does this happen? Well, it's just a lot of elastic collisions. See, I'm dropping these at the same time, but they're not connected in any way. They're separate objects. So ball 2 hits ball 3, first in an elastic collision, causing a velocity exchange. The exchange continues until the last ball flies off the end. Now ball 1 collides with ball 2, which has recently stopped. The exchanges continue until it reaches ball 4, which, with ball 5 already moving away, has nothing to collide with and flies off the end. Congratulations! Now you understand elastic collisions.